Hey guys, so we got ourselves transitioning from arithmetics to algebra and immersing ourselves into linear equations in one variable. But it's time to take the next step to move on from linear equations in one variable on which we now have a grasp, are now comfy with, to the next chapter of the Math by Ear series, linear equations in two variables. But before we move on to the chapter itself, I want to offer an important clarification about the structure for the lessons for this chapter. I will be first covering the entirety of the algebraic representation and methods of linear equations in two variables. We will only then move on to the geometric or graphical representation of linear equations in two variables. The reason why I explicitly point this out is because most teachers and textbooks teach the algebraic and graphical aspect of this topic simultaneously. And whilst I do think different branches of mathematics have a lot in common and go hand in hand, I think for blind students, the first encounter with graphs should be done justice with. I give you the time to slowly and steadily get a feel for graphs and be comfortable with mentalizing them. Also, before diving into linear equations in two variable, let us get a quick recap of linear equations in one variable. So what were they? Let's look at it term by term. Linear means it's just x or it's y. It's not a square root of x or a fourth root of x or an x cubed or x with any indices or exponents or raised to the power of. Now, if you don't understand exponents right now, don't worry at all, but just know that as long as the equation does not have something fishy going on with the variable other than a constant coefficient like 3x or 5y or 10z, then that equation is linear. What is an equation? It just sets two expressions to be equal to one another. So something, the equal to sign, something else. What do we mean by variable? It is just one of those random alphabets A, B, P, Q, alpha, beta, X, Y, Z that represent an unknown value to us. So what is a linear equation in one variable? The general form of that is ax plus b equals to 0 or ax equals to b, where x is the variable, a and b are the constants, and a not equal to 0. Not equal to 0 just because of the fact that we want that one single variable to really exist. Now, one point to clarify here is ax plus b equals to 0 and ax equals to b are really the same thing if you think about it, now that you have knowledge about the balancing method, the transposition method to solve linear equations. Why? Because let's say I give you the equation x plus 1 equals to 0. You can transpose 1 from the LHS to the RHS such that it becomes positive to negative and becomes x equals to minus 1. Now, this is a linear equation in one variable in either ways. Just that when you say x plus 1 equals to 0, it looks like ax plus b equals to 0, where a is 1 as well as b is 1. But when you say x equals to minus 1, it looks more like ax equals to b, where a is 1 still, but b becomes minus 1. So shifting the constant does change its value in terms of its sign, but does not change the fact that it is a constant and it is there following the same format of a linear equation in one variable. Alright, with all of the formalities out of the way, it's time to actually get into linear equations in two variable. And how are we going to do that? By solving a bunch of questions. Now, you might ask me, Bhavya, we haven't even learned linear equations in two variable. Teach us something before questioning us. To that I would say, A, I'm not the most merciful teacher anyways, and B, I think you all are smart. If you cross-apply your existing knowledge of linear equations in one variable, then I think there is a good chance that you will be able to solve the vast majority of the incoming questions. Give it a go.
Determine which of the following are linear equations in two variables, and which are not.
Pause the video after hearing each question and give it a shot yourself before you listen to Bhavya's solution. Question 1.
A plus 2b.
A plus 2b, so you've got a and b as your two variables, and well, 2 is just a constant coefficient of b, so no worries, so it all looks linear. Looks good except for the fact that this isn't an equation, it's just an expression. There is no equality to something else, no equal to sign at all. Therefore, you can say that this is a linear expression in two variables, but it is not a linear equation in two variables.
Question 2.
2y plus 3x equals 2.
Two y plus 3x equals to 2. You've got two distinct variables again, and it all looks linear. This time it's even an equation. There's an extra constant hanging there on the RHS, or 2. But, well, just like in linear equations in one variable, there was always that plus b, that random constant, hanging out there with all of the other variable terms. So, all looks fine here. So let's call this a linear equation in two variables.
Question 3.
3p equals q.
Three p equals to q. Now variables of course can be represented however you want, whether it's p and q or any other alphabet of your liking. So the variables are there, and there doesn't seem to be anything problematic going on. Well, the variables are on two opposite sides of the equation, but I don't think that has any bearing on this being a linear equation in two variable or not. Why would it? So, since everything looks good, let's just call this equation as well a linear equation in two variable.
Question 4.
3x plus 5x equals 8.
This is an interesting, slightly tricky and multi-layered question which I want you to treat with importance. Spend as much time as you want thinking about this question and how you might solve it and explain it. But at the end of the day, let me tell you what's going on step by step. 3x, 5x, so two instances of the variable x, so that is two variables ticked. But are these really two distinct variables? X is really just one variable, so we can club this to show it for what it is. 3x plus 5x, 8x. So this equation becomes 8x equals to 8. You would now be tempted to say that this is a linear equation in one variable, not a linear equation in two variables. But what if I do a little bit of math magic here, pull a rabbit out of a hat, create a new variable and make it appear somewhere in this equation without changing anything? Here's how we will do that. 8x equals to 8. Therefore, 8x plus 0 equals to 8. Adding a 0 to anything does not affect its value, so no harm done. Therefore, 8x plus 0 into y equals to 8. 0 into anything always gives 0. So 0 into a variable can be used to replace the 0 present here. Therefore, the equation is now not 8x equals to 8. It is 8x plus 0y equals to 8. So you have got two variables, x and y here. Therefore, this does become a linear equation in two variable. But then you might argue with me saying that, well, by that logic, if you can always insert a random variable out of nowhere into an existing equation, then every linear equation in one variable can be thought of as a linear equation in two variable. To that I would say that you are correct. But then you would go a step ahead. Where is the limit? You can add a third variable, a fourth variable, as many as you want. To that I would say you are again correct. A linear equation in one variable can be treated as a linear equation in 2, 3, 4, etc. variables. As long as there is one variable that actually exists, which is to say it has a non-zero constant coefficient, then it is a linear equation. Now there is a little more clarity that will unravel this mystery in its entirety, but which I cannot break to you right now because that comes under graphical representation. So stick with me till then, but I hope in general you can understand how 3x plus 5x is just one variable, 8x, but you can have that extra variable term through a 0y or a 0z coming up to serve your needs. Therefore, this is a linear equation in two variables. Having solved all of these questions and worked on the identification of things as linear equations in two variable or as not, it is finally time that I give it away to you and teach you what a linear equation in two variable actually is. The general form of a linear equation in two variable is a into x plus b into y plus c equals to 0, or of course alternatively a into x plus b into y equals to c, where x and y are two variables which could have been represented by another pair of alphabets as well, and a, b and c are constants. The condition here worth keeping in mind is that a and b cannot both be 0 for this to be a linear equation in two variable, which is to say that a can be 0, but in that case b must be non-zero, or b can be 0, in which case a must be non-zero, but a and b cannot both be 0. Of course, both of them can be non-zero at the same time. With this definition in mind, if you were to go back in this video, review all of the questions that we attempted and think of all of them in the context of this general form of a linear equation in two variable, then you will be able to fully understand why we did what we did and how we arrived at the answers that we did. One question that might puzzle you for a fleeting instant is question 3, which was 3p equals to q, because in both of the variations of the general form of a linear equation in two variable, you had the two variables on the same side of the equation, whereas in 3p equals to q, they are on opposite sides. But again, if you think just a little bit more and apply the transposition or balancing method, then you can shift the q from the RHS to the LHS, becomes positive to negative, and thus the equation changes to 3p minus q equals to 0, and this is perfectly comparable to ax plus by equals to c, wherein a equals to 3, b equals to minus 1, and c equals to 0. 3p minus q equals to 0, which is 3p equals to q, therefore is a linear equation in two variables even within the framework of the general form of the linear equation in two variable. Alright then, that's the end of this video. Comment your doubts below, subscribe for more, share this with your friends, teachers and classmates. Catch you in the next one.